Hi, the purpose of this video is to get you started with RStudio Server and working on the first homework. So let's scroll down to where we have RStudio web server link, and you need to be connected to the internet to do this, but please click on there and you'll see this kind of login screen. You will type in your University X500 username. Mine happens to be Anderson. Maybe for you it's Ander0593, but put in your university user ID and then your university password that you would use to access any of your university email stuff. We'll see if I can do that successfully. And then sign in. And you should get to a screen that looks like this. Over on the left you have something called console where commands will be executed. There is a place up here for environment where your data sets and your data definition and variables will be located. You have a lower right corner down here where there is a section called files, where your working files will be located, data files and program files. There's a tab for plots. When you create graphics that you want to view interactively, they'll be under plots. Packages will be parts of the R system that we'll need to install and do things for, and that's kind of the overview of the areas. If you ever get stuck so that the system just doesn't respond and it's acting glitchy, probably the thing to do to try to clear everything up and start over is to go up to the Session tab and just do Restart R, and it will kind of shut down the current session and start a new one and just sort of clear the decks, and that will probably remove a lot of trouble that you might have. The other thing you could do, of course, is go up here to the upper right corner and sign out and sign in again. Basically, a lot of problems that you might have are just caused from just too much clutter, and you just need to shut everything down and start over again clean. Well, right now we have our RStudio workspace and work area set up to do something, but we really don't have anything in here to do. So let's go get some tasks and start working on the practice homework assignment. So I'm going to go back in my browser to the Statistics3601 page, and I'm going to scroll down to topic 2, which was about our practice homework, and you will notice there is a link called R Markdown File for practice homework. And what we're going to do is take this list of instructions and upload it back to RStudio so we can do some work. You'll notice that right below it there is a processed version of that document so that you can see, and it's a web page, and so you can click on this and you can see a version of what our homework is eventually going to look like roughly. There's going to be some graphics, there's going to be some output, and then we're going to supply some typing and some analysis. But that is ultimately what the RStudio process is going to produce, is a nice formatted web page like this. So let's see if we can do that. Let's click on the R Markdown file for practice homework, and let's click on it, and it will ask you, what do you want to do? Do you want to open it? Do you want to save it somewhere? And I think the best thing for all of us is to choose save the file or download the file to your local computer. And let's click on that and do OK. And you can see that right up here, I'm in Firefox, the downloads folder just had something added to it. And so on a Mac, I think there's a downloads folder there as well. This markdown file, this instructions file, has been placed on your computer somewhere, and it's going to be our job to go retrieve it. Once that's been placed on your computer by clicking on this markdown file, you'll click on RStudio, and making sure in the lower right corner that you're in the Files tab. You will want to go to the little orange gold thing called Upload, and we are going to try to bring those instructions from your local computer or device up here to the RStudio workspace. And so it says, what files do you want? Well, we got to go find them, so let's browse. And we open up all our computer stuff, and I'm going to go to the Downloads folder, and I will see that there is a practice markdown file right there. That's the one I just got, and I'm going to click on Open, and then I'm going to click on OK, and you will notice that after I click OK, there's going to be an additional file right here in my workspace, in my files. So I click OK, and now I have a file there called Practice Homework Markdown. This is the file I'm going to use to do all my work. And here's how you use it. Once in this area, just click on Practice Homework File right here, and it should open up a new window over here in the upper left called Practice Homework Markdown File, and you'll see there's a practice. You can make these windows a little bit bigger and smaller so you can see things better. We don't need the console to be quite so big, and we can move it down a little bit. So here's this file of instructions. It's called Practice Homework, and there are some shaded areas, and these shaded areas are called code chunks, and these are going to be pieces of our instructions that the statistical software is going to run. And then places that are not shaded are going to be text or typing, like a Word document. And if you want to see the connection between the Markdown instructions file and what your file will look like, what we can do is get it ready to run, and we can process and sort of see what will happen. Before we do that, though, we're going to need to do some preparation of RStudio, and you can see right here in this second code block, there are some lines, line 12, 13, 14, and 15, about libraries. And there's going to be some add-on components that we need to install for RStudio. We need to install the KNITR or knitter package. We're going to need to install the car package. We're going to need to install ggplot2. It's a graphics for making graphs package. And we're going to need to install some data sets and code from our textbook, ALR4, Applied Linear Regression, 4th edition. So before our instructions file can work very well, we need to go and we need to prepare our version of RStudio for packages that we need. So let's click on the Packages tab over here in the lower right, and let's go to Install Packages. And let's list the ones that we want to install. We want to install knitter, K-N-I-T-R, and you'll notice there's a version of that package, and you can just click on it. And then once that one is listed, you can just do a space, and let's do the next one, car. And there's a package there. It's finding that, and we can do space, and then let's do ggplot2, and let's do ALR4, and then let's click on install, and all of those additional components will show all the installation being done down here in the lower left in the console. And hopefully this will all install correctly. This will be just like how it will appear for you. You can see a little red stop sign there that tells you that R is in RStudio are processing and in installing those new components. And it looks like it's partway through installation. And we'll just wait a moment till it's done. Okay, it looks like it finished. It says the downloaded packages are located in this kind of a directory, and there's no errors or anything, so that looks good. And I'll just move this down a little bit. And we can look over here under our packages list, and we can see that ALR4 has been installed, and a bunch of the other ones, the car package, has been installed. So we're all good to go there. And then what we'll do is we'll click back over here under Files, so we can see our files that we've got. And then I think what we should be able to do is go over here in the upper left to the little knitting needles and the ball of yarn and click on what's called Knit HTML. And so let's click on that, and you will see our studio process our instructions and make a nicely processed version of what we told it to do. So let's start looking at it and making the correspondence. But maybe before we do that, notice down here under Files you have a new file listed here called Practice Homework Markdown HTML. This HTML or web page file is what you're viewing right here in this window, and this is what you will submit to me for homework on your Moodle site. So let's do some work on it first before we do a submission. And let's compare the knitted file on the right here with what's in the set of instructions that were processed. First of all, we notice in our processed file it says first name and last name. Well, let's go fix that up, and let's put our real first name here. So let's put John, and then let's put Anderson right here, and that's how you get your name. You notice when I started making changes and typing things, there was a red asterisk that says that the changes have not been saved. So if you want to save your changes, you can just click on the save document, and you will notice that the date and the time down here in the files area has been changed, and we've made that particular change. Let's go have a look through this instructions file and see what all is in here. Well, this first block of code that starts on line 29 and ends on line 35 goes out to the internet to a place where a data set called Camp Lake has been stored. And what this line 34 does is it reads the data from this data file that's out on the internet somewhere and puts it into a data object called Camp Lake. And that's all that does, is it creates a data set for us. And then in problem 1, it says provide a histogram of the bluegill lengths that are in Camp Lake. That's evidently what is in this data set, is some information about bluegill lengths for Camp Lake. I'm going to go ahead and process that so that you can see it in action again. It looks like the processing window is in the back, so let's figure out how we can get it. We can move it a little bit smaller, and we can see the file that was created. Otherwise, we can go down here and find it. And so under problem 1, part A, it says provide a histogram of bluegill lengths from Camp Lake. 1 point for this. And that was carried out over here in line 37 about providing the histogram of bluegill length in Camp Lake. That made this text right here. And then we had a code block that says with Camp Lake, make a histogram of a variable in there called length. And so line 42 in your practice file made the histogram that you see right here in the processed web page. And so I think you can see here that there's a little bit of evidence that the distribution of the bluegill lengths are maybe a little bit skewed left. It looks like the data are kind of more highly concentrated over here on the right, and a little bit of a longer tail coming off to the left. Not real obvious, but I think a little bit of skewed left. And that brings us to part B of this question. The shape of the distribution is, and it says give the description here. So I think what we would do in that case is we would hit return and type our answer. I think the shape of this distribution slightly skewed left. And I've made a modification to the homework file, and if I want to process that, I'll just go up here and process and knit my changes, and you'll be able to see it over here. I've now modified the file, and it says now I think the shape of this distribution is slightly skewed left, and I made that modification when I typed it right here in line 47. Let's see, I might get rid of that right now. The next thing in our homework says to test the null hypothesis that the average length is equal to 150 millimeters versus the alternative hypothesis that the average length is not 150 millimeters. If you look over here on the processed file, you'll see that we've got the symbols mu and 155 millimeters, and the alternative hypothesis mu is not 155 millimeters, and those symbols were created over here in the markdown file inside dollar signs. You'll notice on a lot of markdown files, anything that takes place in between two pink dollar signs will get represented in mathematical notation. And you don't need to use that, but I just want you to be aware of that's how we're getting the Greek symbol mu, is because we're within two pink dollar signs, and I have a slash mu, which makes the mu symbol. So there's a hypothesis test going on here, and this is a review of some introductory statistics. This is a t statistic that needs to be computed here. We need to take x bar from the lengths, and we need to subtract off 150 millimeters from the null hypothesis, and then we need to divide by the standard deviation of the lengths and take that divided by the square root of n. And so we need some of these summary statistics computed, and how do we do that? Well, inside the code block here on line 54 or close to that, code block called camp sum stats, we will calculate x bar because we'll use the Camp Lake data frame. When it says with the Camp Lake data frame, calculate the mean of the length variable, and so that will calculate the average length, and it will put the average length into a variable called x bar, and then it will go ahead in line 57 and it'll compute the standard deviation of the length. In line 60 it'll calculate the length, or the number of observations that are in the variable length. That's basically n. And then in line 62 we'll calculate the t statistic, and when we type and it'll put the t statistic into a variable called tstat. When we just type the name tstat in line 63, it will just feed back to us the name or the value of the t statistic, and you can see that getting done over here in the processed file. We calculate tstat and we get a t statistic of negative 2.366. T distribution needs degrees of freedom, and so we will get that here in line 64, and we'll take the sample size and subtract 1, n minus 1 for the degrees of freedom from the t distribution. And then in line 66 we will use a built-in function in R to calculate the probability of getting a value of a t-statistic more extreme than negative 2.366. Basically what we need to do, if you look here at the instructions, basically what we're doing is we're finding the probability of getting a value of t greater than 2.366 and then multiplying that probability by 2. And that's how we get the p-value that we get. You can see from the printout that p-value is basically about 0.02117. And then you would proceed in the markdown file down to line 93. And I just want you to notice what happened here was there was a variable that was created earlier on in line 82 for the p-value. And so I can access a variable that's been created in a code block, and you can see me doing that here in line 93, where I say the p-value is, and then I do a backtick key, and then a little r, and then the name of the variable, and then an end backtick, and that tells RStudio to go into the value of this variable and place the value right here in the text. And I don't think you really have to use that much, but I want you to know that this 0.0212 that is showing up here in the text is here because I've accessed it using this backtick r and then variable command. And then we get to the point where we need to do a conclusion for our test. And this might be a little bit of review for you about how to do hypothesis test conclusions, but we had a very small p-value. So I'm going to modify line 104 and say the data are unlikely to occur under the null hypothesis, because after all, this was a small p-value. That means as a review of what a p-value is, it's the probability that you could get data like this happening from a population that had an average length of 150 millimeters. And we just found that probability was very small. It was below 0.05. So the data are unlikely to occur under the null hypothesis. There is evidence to doubt the null hypothesis. So I'll make sure my typing says there is evidence. And that means that there is evidence to suggest that the average bluegill length is different than 150 millimeters. And then in here it says, give more detail in which way that the average differs. Well, what we observe is because X bar was greater than 150 millimeters, there is evidence the average length of bluegills is greater than 150 millimeters in the population. And I know X bar was bigger than 150 millimeters because I can see it right in here where, I'm sorry, it was less than 150 millimeters. So I look at X bar and I see, oh my goodness, X bar is substantially less than 150 millimeters. So what I will do is I'll make sure I say the right thing. Because X bar was less than 150 millimeters, there's evidence that the average length of the bluegills is less than 150 millimeters in the population. And that is how you would answer this question. Let's knit the result. And you'll notice it process, And then on my homework file, you'll see I have an appropriate conclusion for this test. And then what you need to do is go through the rest of things like we've done here, except for this New York error problem. And when you're finished answering your questions and producing the confidence interval. So in the New York error problem, you read some data from the internet and you compute some summary statistics like X bar and the standard deviation and the sample size. It says produce a 90% confidence interval for the average value of ozone. And it says show the components of the computation. Well, if you remember how to do a confidence interval, you need to do X bar plus or minus a multiplier from the t-distribution, and that gets done right down here in my file 148 and 149, where we use the QT function in R to find the confidence multiplier for a 90% confidence interval. The thing you got to remember is if you're doing a 90% confidence interval, it means there's 5% of the distribution on either tail that you're trying to cut off, and that means the appropriate multiplier needs to be a value of t that is at the 95th percentile. And so how do you get the value of t at the 95th percentile? Well, it's the QT 0.95 function, and you put in the right degrees of freedom. And ultimately this code produces a appropriate confidence interval that goes from 36.86 units of ozone up to 47.37, probably parts per million or parts per billion. We would have to look at the definition for New York Air dataset to determine that. But when you have finished with your work, let's try to submit your homework. So let's suppose we're done answering the questions and so forth. What we want to do is we want to get this HTML web file down to our computer, our local computer, and then uploaded as a homework. So click the checkbox right here, and then let's go over to the More gear wheel and click on Export. And when that file is checked and we click Export, it'll say, what do you want to do? Well, let's download it. And so we'll download. And what do we want to do? Well, let's just save the file to our computer. And it goes into our Downloads folder. And then we go back to our class Moodle. And we go to Practice Homework, Written Assignment. And we click on that. And we go down to the bottom, and there will be a upload for students. There will be an upload link, and you'll be able to upload your file. Okay, let's try that again. Practice homework written assignment. Back on the main Moodle page, on our main Moodle page, under topic 2, practice homework written assignment. This is where you'll upload, and down at the bottom it says add submission, and it'll show you where to put your file. And what you can do is you can open something on your computer and drag the file icon in here, or you can go to right here on Add, and it can say go find the file that you want. So we'll go do that, and we'll browse. We'll go to Downloads, and it says that it's this practice markdown file. I probably could just go drag and put it right here if I wanted to, but we'll select it, and then we'll put that file right in here. Should load in there, and that should get your practice homework markdown file into this upload area. The other thing you could do, if you ever want to have a file go away here, is you could delete it, get it out of here, and you could go up to your downloads area and find the file that you downloaded and drag it in here, and that would also be a way to do that, and then save changes, and your homework has been uploaded and it's been submitted for grading. And I think if you ever wanted to change something that you've submitted, if it's been turned in before the due date and you want to get it back again, I think you can just do edit submission, and it should open up the area for you, and then you could click on the file, delete it, and put in a new version if you wanted to, and that would be a way that you could modify a submission before it had been graded. Hopefully that will give you an idea about how to execute and do work on RStudio Server and submitting homework. Other things that you would need to do for your practice homework is to do the electronic quiz portion, and then at the end of all that, grading and electronic quizzing, you'd be able to access the solution key and a grading guide. As soon as everything has been processed and grades have been given, you could see the solution key. You can also do all of this RStudio work from a personal installation of RStudio, but you don't have to. So we'll go back to our RStudio session, and we'll just sign out, and we're back to the sign in screen, and I'll just sign in again for you to show you what happens when you sign in again. When you sign in again, you will notice that all your files and all the work that you did in your previous session are still sitting here, and you could resume work in your RStudio server if you wanted to, or you could upload a new file or a new homework or whatever you wanted to do. So I hope that's helpful. Please let me know if you have questions.